Yep.
Went okay?
Pardon?
The test went okay?
Yeah, I think it went pretty well. Yeah, it went pretty
There wasn't anything that seemed outlandish or
well. No, pretty similar to things that we've covered and talked about.
okay, good.
Yeah. So I just had a question. I was just starting to work through 3.2's homework.
Okay.
And it was question number 5, 3.2.5. It's talking about like a shifted exponential.
Yeah.
So I got the part A, the CDF, but then when I went to part B to get the mean, I was a little bit confused when I was looking at the back of the book versus what I had come up with.
All right, well, let's take a look.
Okay.
This kind of stuff is a little bit when you have these indefinite integrals that have endpoints, it starts to get a little
Yeah.
especially if you haven't been doing it for a while. So let's see here. Plug-in is what are you talking about? Plug-in. Sorry.
Oh, no worries.
I don't know why it's telling me right now I need to install a plug-in. Transfer please try again later. What is going on? Well, here, let me do this. Here, I'm just gonna see if you can see that, right?
Mm-hmm.
Okay. Let me go like this. What? Yeah, I don't know. I'm gonna have to mess with this thing. Let's see. I wonder what would happen if I did a screen mirror. Something's up with this thing. Well, in the worst case, I could always use that lousy thing here. Do that right now.
Yeah.
Okay, so can you see that?
Mm-hmm.
Okay, so for the CDF,
Mm-hmm.
so you knew how to do that. So first of all, X has to be bigger than delta, right?
Mm-hmm.
So like capital F of X, capital F of little x was equal to, oh my word. Okay, the integral from, from delta up to x of this thing?
Mm-hmm.
1 over, for some reason they decided to use this parameter theta.
Mm-hmm.
It was e to the minus, was it x minus delta over theta?
Mm-hmm.
Oh, x minus delta over theta. I mean, this thing looks horrible, but
I know, I got you.
dx. Okay, so
Mm-hmm.
did this, oops, oh, right, so delta up to x of this thing, right? So what is the antiderivative? What did you get for the antiderivative of this?
So I did like a U sub with like all the stuff that's to the power of that e's to the power of as my U. And I think I got like negative e to the negative x minus delta over theta du, and then plus c, which I think would just be 1 according to our formula.
So did you just put you said you put u equal to 1 over theta times x minus delta or something?
No, so my u was negative x minus delta over theta.
Okay, so it was you actually took the negative into it as well. Okay,
Mhm.
so basically that's what you put u equal to.
Yeah.
Okay, so then du was like negative 1 over theta,
Hmm.
negative 1 over theta dx. Right?
Hmm.
And that's almost what this is. Like you have a 1 over theta right here, right? And you have a dx
Yep.
here, but you need it to be like
Hmm.
negative, right? So there's going to be a minus sign that pops out, and it's going to be the integral. Uh,
Hmm.
now it's going to be du, and you have just e to the u, right?
Hmm.
E to the u du. And okay, what are the new limits of integration?
Um,
If you take x to be delta, what's u? Because this was x going, oops, sorry, this was silly. I shouldn't have used x in here. I should have used like t, right?
mhm.
But so if I take the thing to be, uh, if I take the variable, if I take the variable to be equal to delta, what do I get for u?
You get 0.
Yeah. And then what if I take the variable to be x?
You just get your u.
Right. So it's just going to be x or negative, right? Negative 1 over theta, negative 1 over theta x minus delta, right?
Hmm.
Okay. So then what did you get? You got, I'm assuming what you got was, so the antiderivative of e to the u is just e to the u, correct?
Hmm.
And then you got e to that minus 1, but it's going to be actually 1 minus e to the uh, negative x minus delta over theta. Is that what you got?
Hmm.
Okay, so that's what you got for the CDF. Okay. And then it says calculate the mean and variance of this thing. Calculate the mean and variance of this thing. Well, probably the easiest way to do that, Aaliyah,
Hmm.
is to find the moment generating function.
Oh, okay.
So what's the moment generating function going to be in this case? Okay, so it's going to be m of t equals what? Well, it's going to be the integral. I'm actually going to go the integral from delta to infinity, right?
Okay.
The integral from delta to infinity. This is supposed to be a delta, not a 6, right? From delta to infinity, and then it's going to be e to the tx times the density. It's going to be e to the tx times the density. So, I mean, look, I could take the 1 over theta outside here,
Right.
okay? So
Hmm.
e to the tx times this other thing. So can't I just put that all in the power of e? So it's going to be e to the tx,
Oh, right. Yeah. Times all that.
e to the tx minus what?
The x minus delta over theta.
Right. And that's dx.
Hmm.
And I think that you should be able to. So for instance, uh, okay, uh, um, so some of this, so okay, so what is this? So isn't this thing just like e to the, like, what is x multiplied by? E to the x. And what's x going to be multiplied by? Parentheses. There's going to be a t, right?
Yeah.
And then what else?
You have to distribute through the
Yeah,
negative.
so it's just going to be minus
Um, oh,
t minus 1 over theta, isn't it?
okay.
Isn't that right?
Oh yeah, yeah.
Close parentheses, but then there's more, right? What else is in the power?
Um, Something with delta, I'm assuming.
Plus, right, it's plus delta over theta.
Over theta. Okay.
That makes sense?
hmm
So, first of all, we need to know something about this. Like, in order for the power of the exponential, like x is going to infinity. You understand? X is between delta and infinity.
hmm
We need the number that's attached to x to be negative in order for the integral to converge. Otherwise, this thing is going to be blowing up as x gets bigger instead of
Right.
getting small. As x gets bigger, the exponential needs to be getting smaller. So what needs to be true about t and 1 over theta?
They have to be less than 0 when you subtract.
Right, right. So t basically has to be less than 1 over theta is the ultimate conclusion, right? Like t minus 1 over theta needs to be less than 0. Yeah.
hmm
Does that make sense, Aaliyah?
hmm
So,
hmm
okay. So like what's the antiderivative of that junk? Because remember, the antiderivative is with,
Of what? Sorry.
huh? What?
What was that? Sorry, my computer froze for a second there.
Okay, so what is the antiderivative of this junk? Keeping in mind that the variable of integration is x, right?
hmm
So what is the antiderivative of this garbage right here?
It would just be e to that all that stuff times du, which would be t minus 1 over theta.
We 1 over that, right?
Yeah. Right. Yeah.
So watch this. I'm going to have 1 over theta. The 1 over theta is this 1 over theta right here, yeah?
Okay.
And then it's going to be 1 over t minus 1 over theta, yeah?
Yep.
And then this exponential, e to the blah, right? I won't write the whole thing up there, but it's just e to the
Yeah.
stuff, yeah?
Yep.
And I have to evaluate this between where and where?
Uh, Delta and infinity.
Yeah. And the way that we cooked this up, since t is less than 1 over theta,
Uh-huh.
this is negative. So as x goes to infinity, this exponential is going to die. Yes?
Right. hmm
That will decay to 0. So the only thing
Okay.
to worry about is plugging in x equal to delta. Does,
Okay.
does that make sense?
Yep.
So
Yeah, because that first
again,
term will shrink to 0.
yeah, so the first term, so it's going to be minus this thing with x replaced by delta. Does that make sense?
Yep.
But what happens, Leah, if I replace x with delta? If I put delta in for x,
You're gonna just get delta t.
yeah, because this junk right here is going to cancel. Do you see that?
Right.
This and this would end up canceling. That's nice.
Yeah.
So it will just be delta t. Okay, so what am I going to get for the moment? This thing's going to work out pretty nice. That sort of tells you that it's got to be right.
Yeah.
So it's going to be e to the delta t. Oh, man, and look at this. Don't you see that like this, if I distribute this in here, aren't I just going to get theta t minus 1? And by the way, all of this it has a negative sign attached, right? Because it was evaluated at infinity minus,
yeah.
evaluated here. Okay, so I could take care of that by flipping these guys around. Does that make sense? Like multiplying by a minus sign, I could that flipping those guys around. So isn't going to be like 1 minus, so 1 over 1 minus theta t. Oh my word. Okay. Theta t, and then what's the exponential we said that was going to be there?
Just e to the what was it? E to the delta t.
E to the delta t, yeah. Okay, so that's a pretty simple moment generating function. So then what would I have to do to find, so e to the delta t over 1 minus theta t. Can I erase this?
Yeah.
Okay, so you have that written down? So, oh, wait, what am I doing? How do I write here? I think I don't even know how to get back into writing mode.
It's all good.
Oh, I did do the right thing. So what was M of t? M of t was?
M of t was e to the delta t all over 1 minus theta t.
That's almost kind of like what we had for the exponential. Remember the exponential was 1 over 1 minus t over lambda, but 1 over lambda was like beta. So I mean, it was this was almost exactly the same, but the price that we've paid is we have this extra like exponential factor up here.
Okay.
So what's the derivative of this?
It would be, you have to do the quotient rule.
Right. So first of all, we just put the denominator squared, right?
Yep. And
then upstairs, what do we have?
1 minus theta t times delta e to the delta t.
Yeah.
And then minus e to the delta t times negative theta.
Yeah, so it's plus.
Right.
Plus theta e to the delta t. Makes sense? Okay, and we'd best simplify this. Maybe. So what happens if what can we factor out of this?
1 out of, or wait, e to the delta t on top.
Yeah. And what's going to be left behind?
It's gonna be, is that a delta?
Yeah, that's a delta.
Delta times 1 minus theta t.
Yeah, delta. So it's going to be basically delta plus theta minus delta theta. Oh my word. Delta theta t. Make sense?
Yes.
Over 1 minus theta t squared. Okay. So what is the expected value?
So you just plug in 0. So you'd get minus, so it'd just be delta plus theta.
Yeah. What did the back of the book say?
Yeah, that's what I had.
Okay. And I mean, well, I guess I'll leave it up to you, but to get the other thing, you would have to take this thing right here and then just take the derivative again. That's going to be annoying because the top is, you know, a product.
Yeah.
But it's definitely doable.
Okay. Gotcha. I think what I was trying to do was like declare what lambda was, and then get like use the equations we had in the notes where like the expected value was 1 over lambda.
Oh, yeah.
Yeah.
Um,
But I wasn't getting the delta in the that equation.
there might be a way to, well, there might be a way to pull that off.
Yeah, it was like I was just confused because it seemed to work for the variance. So when I had done it, I said that lambda was 1 over theta, and so the variance would have been like theta squared, which it has in the book. But then I saw the expected value was delta plus theta, and I was like, oh well, that's something's different there.
Yeah. I think there probably is a way to recast it that way. Yeah, and maybe handle it. And it makes sense that the variance wouldn't really change, right?
Right. Yeah, because it's just shifting it one way
It's
or
just
another.
shifting it so the variance would be the same, but the mean is what's going to change. Yeah.
Oh, yeah. I guess intuitively that makes sense.
Yeah. So
Okay. Yeah.
you could push the moment generating function. So I mean, but we were able to actually
Yeah.
track the moment generating function, which is kind of nice.
Okay. That makes sense. Yeah. Thank you.
Yeah. What else?
I think that was it as of right now. That was as far as I got though.
Okay.
Yeah. I did.
Lectures made sense though.
Yeah. Yeah. Um. Yeah. I saw the chi-squared one. Yeah. I understood how you did everything. I wasn't 100% sure what like all the variables meant and stuff, but it sounded like you were gonna maybe get into that a little bit more, a little bit sooner.
Which variables?
Like R is equal to like degrees of freedom,
Oh, yeah,
stuff,
that's right.
stuff like that.
I mean, what that means,
Hmm.
uh,
Yeah.
that's something that will become clearer once we start doing some statistical applications. So, I mean, degrees of freedom,
Okay.
I mean, we just say that right now, but we don't really explain what that means until later when it's like, oh, now I see why we were calling that degrees of freedom. Basically, what the degrees of freedom will end up being.
Okay.
I mean, like if I have 5 numbers,
Mm-hmm.
like, and I tell you what the sum of them
Mm-hmm.
are, like if I say, okay, here's 5 numbers, the
Mm-hmm.
sum is 50. Okay, then basically I can take any numbers for the first 4 of them. Like, I don't know, you could say 2, 7, 8, 3, and 1. 2, 7,
Mm-hmm.
2, 7, 8, and 3 or something. And then the 5th one, though, is going to be determined if I tell you what the total sum is of those numbers.
Okay. Yeah.
Your degrees of freedom in that case was 4. And that's the kind of thing we're going to be doing later on. You're going to have
Okay.
numbers, and we're going to say, oh, the degrees of freedom is 1 less than that because I have total freedom with the first n-1 things. But if somebody tells me what the sum is, the last one's gonna have to be something to make it all work out.
Gotcha.
Does that kind of make sense?
Yeah. Yeah.
That's what the degrees of freedom will be for us eventually. But for right now, we just say the degrees of freedom are just this weird parameter.
Okay. Yeah. Everything else made sense. It helped a lot when you like drew the graph and kind of like denoted the area that we were like trying to find. Like that was helpful for sure.
Yeah. That is helpful. Yeah. And the
Just
chi-squared,
to like visualize what we're doing.
the chi-squared distribution has this weird kind of skewed shape. And we'll
Mm-hmm.
later on to do some statistical stuff. So,
Mm-hmm. Cool.
anything
Yeah, I
else?
think everything. I think everything else made sense. Yeah, I went through the 3.1 homework and it seemed to all match up and make sense. So yeah, I think I'm.
Okay, cool.
Yeah, thank you for your time.
Yep.
Appreciate
All
it.
right. I will talk to you later, I guess.
Yep, sounds good. Have a good one.
Yep. See ya.
See ya.